Hello students, today we are going to learn about free body diagram. It is very common among all the science and engineering students. Even nowadays, students of standard 9th and 10, even 8 also, they learn how to draw free body diagram. I am D.N.Thatoi. I welcome you all to my new YouTube channel Physics Sketch. So now we'll discuss about free body diagram. So what is a free body diagram? How it is important and how to draw a free body diagram, and we'll learn how a free body diagram helps us to analyze a difficult problem very easily, a complex problem very easily. That's why it is called free body diagram. We will not discuss the entire body. We will be discussing step by step about the free body diagram. So now there will be a big body, so we have to make isolation of a body from the system, and that small part we will be going to discuss. That is called free body diagram. So now before going to discuss about the free body diagram, now first let us learn or discuss about some very important terms regarding the force. So now I am going to discuss about force. So I am not going to define force, that we know. So I am going to discuss the very important terms related to the force. What are these? Listen carefully. This is your free body diagram, very important. So now before going to learn about the Newton's law or the laws of motion, then friction, circular motion, every student, even from the school level, one should learn clearly what is a free body diagram. If one is to learn free body diagram, then important is what is a force. Now I am defining a force, how to specify a force completely. So this very important terms I am explaining, please listen carefully. If somebody will remember what is a force and what are the important features of a force, then free body diagram is not an important part. It is very easily you can draw it. So now first is a force is completely defined by the following terms I am writing here. First is magnitude of the force. First is magnitude of the force. Please note down. So that is the magnitude of the force. Then, so another part is required to specify a force. So now a force will be specified by magnitude of the force. Second one is the direction of the force. Then after getting magnitude and direction, next important point is at which point exactly the force will be acting. That is called point of action of the force. Point of action of the force. So these three are very important. So when you are going to draw a force or you are going to analyze the force of a system, how the forces are acting, what is the action of the force, how the force body will move or it will not move, everything depends upon this factor. One is to understand magnitude, then direction, next the point of action of the force. So now you have understood. Now let us make a point. Note down your points, important point. One is important is the magnitude of the force. Then second point is direction of the force. Third point is point of action of the force. At which point the force is acting. Now these 3 points are important. Now another very important points on the force are, these are the 2 important points regarding force. That is, force are categorized as mainly 2 types. One is a contact force, another is a non-contact force. So if you will understand what is a contact force and what is a non-contact force, then we can able to draw the free body diagram and we can able to analyze the system. Then again I am going to important part. So these are the 3 important points. Another point is force is defined as or classified as 2 parts. One is the contact force. another is your non-contact force. Non-contact force. Now let us discuss what is a contact force, what are the contact forces, and who are the non-contact forces. So the contact forces are, so you know contact forces are, who are the contact forces? Now the contact forces are that is your contact forces are, one is your applied force. Suppose you are applying a force, that is called applied contact force, applied force. So we are pulling a body by connecting a thread, that is called tension, that is your tension. Then you are pushing a body, by pushing a body, so there is a contact force. Then friction, contact force, friction is a contact force. Normal reaction, contact force, normal reaction. These are all the contact forces, because actually they will bodily touch the body and exert the force. Then they are called the contact forces. Then others are non-contact type. What are the non-contact type? Now non-contact type is the earth will attract the object flying in the sky. So now that is the non-contact type. So earth is pulling the body, that is called gravitational force. That is the gravitational force. Another is the electrostatic force. Another is your electrostatic force. Another is your magnetic force. Magnetic force. So these are the classification of the forces. So one is contact type, another is your non-contact type. So contact type forces are tension, the friction, normal force, applied force. Now I am pushing the wall or pushing the board, so a contact force. Now by the help of a magnet, I will attract a iron, so it is a non-contact type. The mango is falling, so that is a non-contact type force, because the gravitational force. So these are all the contact type force and non-contact type force. Now after understanding the contact force and non-contact force, then the magnitude of force is important, direction is important, and point of action is very important. Now the next three parts also I am noting here. Now when we will draw a fever diagram, always I will refer to all these things. So that is your contact force, then is your non-contact force. So now if somebody understands clearly all these things before going to draw a free body diagram, then drawing free body diagram is very easier. So anyway, in free body diagram, what we are going to do? So what are the steps to draw the free body diagram? Please note down the steps to draw free body diagram. The steps to draw free body diagram are: first is isolated a body from a system. First one is there may be a system of many objects, many bodies are close together. Then first one is isolate the body. Isolate the body from the system, from a system. If 2 to 3 objects are there, now you give focus to a single body. All interest will show to a single body. That is called isolate the body from a system. Second one is show all the contact forces. Second step, show all the contact forces. Then third is show all the non-contact forces. Then third is show all the non-contact forces. So all the non-contact forces, and these are isolate the body from the system. So when you are isolating the body from the system, then how this system will be isolated? By representing the forces in contact and by representing the forces non-contact. All forces are shown, then you can say all to draw a free body diagram, these steps are satisfied. This is called all loads are replaced by vectors. So here next image, all the loads will be replaced by vectors, arrows. All the forces are replaced by vectors. Vectors means arrow. The direction, because I told you direction is important. That's why all the forces are replaced by the vectors. This vector now represent the contact forces, non-contact forces by the vectors, arrows. Now this is all about the before free body diagram steps. So these are the steps. These are the understanding required to draw a free body diagram. Then where to apply the free body diagram, or where to apply? Now this free body diagram concept is applicable to a statics problem as well as dynamics problem. That also you wrote down. It is applicable to both static and dynamics problem. It is applicable to application. It is application to a static problem. Maybe the body will rest due to combination of forces, or it is also applicable to dynamic. Let the forces there will be a net force and the body is moving. Maybe moving with constant velocity, maybe moving with a acceleration. Maybe it is a linear motion, maybe it is a rotational motion or curvilinear motion. In all the cases, that free body diagram is applicable. Dynamics problem. So now it is applicable to static and dynamic, and the steps are isolated the body, so all the contact forces, now show all the non-contact type forces, and recognize all the points so that you can able to draw a free body diagram. Now let us go to actual free body diagram. So you will feel all the points I will be applying while describing how to draw a free body diagram. So please follow. So I am solving some examples. So okay, let us solve some examples. Interesting, easy, very easy. It is very easy. So now somebody will ask you, do you know what is a free body diagram? Can you draw a free body diagram? So people generally ask. So you say, yes, I know what is a free body diagram. In addition to free body diagram, you explain so many things. Then it is your task will be over. Then you can excel in your future. So now first problem. Look, the first problem is, so it is an object. Okay, it is an object kept on the ground. So few problems I will be solving regarding free body diagram. This object is placed on the ground. Yes, it is placed on the ground. So now this is ground. Now the body is at rest. Now what are the forces acting on the body? So I told you what are the forces acting on the body. Now first is the weight is acting through the body. Let the mass of the body is, let's say 5 kg. So now weight will be acting about the center of mass of the body. This is the weight is acting at the center of mass of the body. Now another force, the body is kept on the ground. Ground will give a reaction. The ground will give a reaction. So reaction will be acting here. This is the reaction. Ground reaction. Now come to the points I have discussed there. What I have discussed? Now a force is defined by the magnitude of the force. Yes, I have shown magnitude, that is equal to 5 into g. Then the reaction. So reaction will be, if it is balanced, then reaction is also 5g. Second, direction of the force. So weight will be acting at the cg downward and reaction is upward. So direction is, weight is always vertically downward, reaction is always upward. Then third, point of action. The important is, always the weight of the body is acting through the central mass. Sometimes people say the weight of the body is acting on the ground. No, the weight of the body is acting at the CG of the body. In which direction it will act? It will act downward. So you may draw the 5G, this vector you may draw a big one or small one, does not matter. But always you remember, weight of the body is always acting at the center of mass of the body downward. That's why at the center mass I am showing downward. Then reaction. Reaction of the body is, this ground will give a reaction. So now this is the bottommost point. So reaction will come and touch the point. Because when the body is kept here, look. So now this is the object. Now the object is placed on my palm. So now my hand is giving a reaction at the lowest point of the book. So it will giving a reaction at the lowest point of the book. This is the point of action. This is the point of action. We may extend it. That's why the point of action and this. Now, so what I will be doing? Now I will take the body out and I will replace the ground. That is called isolation. Okay. First step is I have to replace the body from a system of the bodies. Now the system of body is two here. One is the object, another is ground. The two objects make a system. So from the system, isolate the body. So 5 kg will be isolated. That means I will show the 5 kg body only. I will never show the ground. That is called fever diagram. Yes, I have isolated. After isolation, I will show the forces, contact forces, non-contact forces. The non-contact forces is passing through the center of mass because the earth will pull it. The earth below it is always pulling it. Then the ground below it giving a reaction. The reaction will be touching here. The reaction is not like this. The reaction is touching here because this is the point of action of this reaction force. This is the point of action of the gravity force. Then the free body diagram is over. This is the question number 1, free body diagram. So try to understand, apply the points while drawing the free body diagram. So don't change any idea. So this is the free body diagram is always like this. Okay, problem number 1 is over. Now come to another problem to understand free body diagram. Next question. So next question is, so I am taking a body so suspended from a string. Look, now this is the roof. From the roof, a sphere or a body is suspended. Now it is suspended from the top point because you know a string will be connected here. Now it is suspended. Mass of the body is equal to 10 kg. Now this is a string. Now it is a roof. So how many objects are here to make the system? So one is the sphere, another is the roof, and the string is connected between them. The connection between them. So I have to draw the free body diagram. So when I have to draw the free body diagram, then I have to find out what are the forces acting on the system. First one is direction of the force. So now the nature of the forces. So direction of the weight of the body, the earth below here, the earth is below here. The earth below is pulling the body downward. That is the weight of the body. That is 10 into g. So this 10g you may draw a small line, you may draw a line, big line. Doesn't matter. But don't say like this. Always draw that this the gravity is pulling the body downward. The force is 10g. When gravity is pulling the body downward, so who is holding the body not to come down? Now the string connected here is giving a force upward. That is the tension. T is the tension that is holding the body. It is holding the body upward. And this same tension is pulling the roof downward. Same tension is pulling the roof downward. My question is to draw free body diagram of this sphere. So anyway, again I am telling what I have done. Now I have done that, and this is a sphere. So now I have recognized the direction of forces. Yes, I have shown direction of the weight, direction of tension. Then point of action, where the weight is acting through the center of mass of the sphere. The tension will be acting at the contact point on the top of the sphere and another contact point at the roof. But the roof I will not consider here because I am drawing free body diagram of the sphere. So this is the contact type. So tension is a contact type, weight is a non-contact type, and magnitude of force I have shown. Now come to contact force, non-contact force, point of action, direction, magnitude. Now it is a static system. So in this system, when I will draw the free body diagram, so only sphere I will take. I will not take the roof. That is called isolation. Now first step is isolate the body. Which body? Now sphere. So I am taking the body sphere. This is isolating. The sphere is isolated. Okay. The sphere is isolated. Sphere is isolated. So if the sphere is isolated, then the sphere will fall down because earth is pulling it down. So since earth is pulling it down, and where the earth will pull? Earth will pull the sphere about the center of mass. That is equal to 10 into g. Because I told you the force is about the point of contact. So point of action, the weight is acting through the CG of the body. CG. So now when it is coming down, so now the string attached this point is giving a tension. So it is a contact force. T is a contact force and mg is the non-contact force. Non-contact force. By the combination of non-contact and contact force, the body is now here. So forces are shown, point of action are shown, contact and non-contact type are shown, then which is upward, which is downward, direction, every shown. This is called the free body diagram of a sphere. So I have drawn the free body diagram of a sphere. Second problem is over. Now similarly, then we will be solving, slowly we will be solving one problem, two forces, three forces like this. Then we can come to a situation where we will find out free body diagram. Yes, I can draw it. So this is how we will be proceeding. Please come to problem number 3. I am removing this part. In problem number 3, so now I am taking the figure like this. Look. So here this is the object. A block. The block is placed on the ground. So when I am drawing the diagram, so always I am giving some clearance. So please give the clearance. Why? To show the friction force, to show the reaction force, the point of contact of the force. This is very important. If you just keep in exactly in contact with the ground, then you cannot recognize on which point, on which body the force is acting. You cannot clearly determine or define. That's why, so always give a gap. So now first point is the body has weight how much? Let the body has weight 10 kg. Let the ground has friction. Now you are pulling the body here. You are pulling the body here. You are pulling, and it is a problem of which problem? Now let it, I have to application is static dynamic. Let it is a static problem. Let it is a static problem. If a static problem means all the forces are balanced. Upward force, downward force balance. Left hand side, right hand side forces are balanced. It is a balance problem. It is a static problem. So first I have defined it. Now let us show all the forces acting here which are not shown. So only one force is shown is the P applied force. This is the applied force. That is which type? This applied force is which type of force? This applied force is your contact force. Because the force touches the point, then it is a contact force. So these things you understand clearly. Then the arc below it, so it pull the body. So it pull the body. Make a small line. Don't extend it. If you extend it, then somebody will be easier to say that this weight is acting on the table or the weight is acting on the ground. Then it will confuse you. So make a small line, because the earth below is pulling the body through the center of mass, that is equal to 10g. That is a non-contact force. This is a non-contact force. Now next force is, this body is placed on the ground. If this body is placed on the ground, so ground is giving a reaction. That reaction will be acting where? Now ground is touching the floor of the block. This is the block. This is the floor of the block. The ground below will give a reaction and it is touching the floor of the block. So that is the reaction. That is your reaction. So reaction, don't draw the diagram that this is the force. A reaction is this. So this way you cannot understand the exactly force, because I told you forces are defined by magnitude, forces are defined by direction, forces are defined by point of action, and the force is a contact type, force is a non-contact type. If you are always applying these things clearly, then your mechanics or your fluid diagram will be clear. So here the force is R, the weight, applied force. Another force I am going to draw, that the friction. The friction I am showing on the body. That's why this gap I am showing, so that I can able to show that the friction is a tangential force. It is a contact type force. Tangential contact. It is contact normal. So this is a friction force. This is friction force. It is a tangential contact force. It is a contact force, but which nature? Tangential contact force. Tangential contact force. Then this one R is the normal contact force. That is the normal. It is normal to the surface. and it is the contact force, normal contact force. Now these are the forces. I am not going to analyze the problem. Only I am showing how to draw a fiber diagram. What is meaning of fiber diagram? The meaning of fiber diagram is isolate test body from a system. That means here this is the body and ground is the another body. So I am removing the ground and I am drawing only the body. So then if I am taking only the body, that means I am isolating the body from the system. After isolating the body from the system, then I am showing all type of forces acting on it. All type means what? All type means contact type, non-contact type, and direction, and point of action, and magnitude. That is called free body diagram. So now this free body diagram is over. So now I am showing this is a 10 Newton acting at which point? The 10 to 10 G will be acting at the CG of the body. Applied force is applied here, contact type. 10 G, non-contact type, gravitational force. Ground reaction is acting at the contact floor, at the contact point floor, normal contact force. Friction, tangential contact force. Why friction is going to left? In order to oppose the applied force P to right, so it is to left because it's a static problem. So right hand side force is equal to left hand side force, downward force is equal to upward force. That are the condition of equilibrium of a body. This is question number 3 is over. Now to come to example 4. So few examples I will be solving in this part. In another part, so I will be drawing some free body diagram and I will go little bit explanation or little bit analysis. That is, when you are riding a cycle, what is the nature of the friction force, and in the friction force on the front wheel will be in which direction, friction force on the rear will be in which direction, while pedaling friction force will be where, and while only going in a top hill, how is the friction force, while running on a road, what is the friction force. All the type of analysis that I will be going in the part 2 video. So in this video only I will explain what is fiber diagram, how to draw fiber diagram of some very simple category problems, and major explanation is this one. So please read, write, practice, and if at the end of this you will be getting that fiber diagram you are able to draw. So another problem I am drawing fiber diagram. Look. This is a roof and it is a wall. In between the roof and wall, a body is suspended. Now this is a body, any shape, any size you take it, body is suspended. Now a string is connected to the here, so that it is wall, at the wall the string is connected. Another body, so this is the weight of the body. The weight of the body, mass of the body, say that is equal to 10 kg. Mass of the body is 10 kg. Now a string is connected to the roof. The string is connected to the roof and this makes angle, let's say 60 degree. So this is the body. Mass of the body is 10 kg. 10 kg is suspended by a string to the roof, inclined string. Another horizontal string connect to the left wall. Now the body is in equilibrium. Equilibrium means static problem, statics. If it is statics problem, then I have to draw free body diagram. Means I have to draw only 10 kg body, removing the roof, removing the wall, and the supports. This support will be represented by the contact type forces or non-contact type forces, and which forces are acting on the body. Now come to the first step. What is the first step? The first step is, first one is find out what are the direction of the forces and what is the point of action of forces, all these things. Let's see. So what are the forces acting here? Now first one I will say that gravity is pulling the body downward. So that is equal to 10 into G. So the weight is equal to 10 G. So that 10 G is your non-contact force. Passes through the center of mass of the body. Non-contact force. Always I am repeating, though it is the same thing, but again I am repeating, that is non-contact type force, that is your gravitational force. It is your gravitational force. The earth below it, earth is here, so earth is always pulling it. Gravitational force. First one. Second one. So this body is suspended by a thread. So thread will pull it up. So again it is a contact type force. Now this thread will pull it up. Now this is the contact. This thread will pull it in this direction. It will pull it. This is the contact type force. And T1 is the tension. T1 is tension. It will pull it upward direction. This is the tension, and it is the contact type. It is your contact type. And another string connected here, that is equal to also a tension, that will, it is pull it to left side, that is the tension 2, that is called tension. This is your tension. This is the contact type. This is your contact type. Now in this body, how many forces are acting? One is the weight mg, another is tension T2, another the force T1. Three forces are acting. Now the forces, what I have done? Direction of forces I have shown. Point of action, yes, this tension is acting at this point, contact force. T2 is acting at this point, contact force. Gravity through the center of mass is a non-contact force. Then contact force, non-contact force, point of action, direction, magnitude. The magnitude what I know I am writing. Those magnitudes I don't know, I am just writing the namings T1, T2. Then after drawing everything, then what I will be doing? I will be removing the wall left side. Then I am removing the wall roof at the top, and only thing that I will say that this angle is 60 degree, because it is given like this. It is given 60 degree, so this is 60 degree I am showing here. Now this representation of this body with the forces shown is called the free body diagram of the 10 kg body. That is called free body diagram of 10 kg block. This is called the free body diagram of the 10 kg block. Okay, now so if you want to say, then again you can also draw the diagram again separately here. This is the body, this is the object, again I am drawing here, please go through it. This is the body. The weight is acting at this middle point, and tensions are acting, the figure I will be showing. The weight will be acting here through the center of mass, that is equal to 10 into G. So here tension will be acting, this is equal to T2. Another tension is acting here. So another important part I am going to explain here. Please do remember, the tension is T1. This T1 makes an angle 60 degree here. This is the 60 degree. Now very important term. Please everybody remember. This is a very important term. Now this T1, T2 and 10 Newton, all the forces should be passing through the center of mass. If a body is in equilibrium means it is a statics problem. Equilibrium, then all the forces should be concurrent. Concurrent means they should pass through a common point. So here the common point is the center of mass. In this problem, the common point is center of mass. They all has to pass through the center of mass here, because common point is the center. The orientation is such that they are passing through the center of mass. In this problem, center of mass, they may not be at center of mass, may be in a different point, but they have to pass through a common point if a body is in equilibrium under three forces. That's why what I have done. So since this point is acting and it is coming to the center of mass, this line has to come to the center of mass. Then it will be all, this is called concurrent forces coming to a single point. This is the problem number 3 or 4. The problem number 4 is over. Now come to problem number 5. Another problem I am showing to draw the free body diagram. So to draw the free body diagram, the next problem is, look. So this is the wall. A sphere is touch. The sphere is kept like this. It is a sphere. Okay, it is a sphere. Now this is the center of the sphere. The wall is smooth, means there is no friction. Now the wall is touching here, in contact here. Now a string is connected at this point. Now this is the wall. Now the sphere is coming and in the wall there is no friction. Weight of the body is equal to 50 Newton given, and this angle is given 30 degree. Draw the free body diagram of this sphere. Question is draw free body diagram of sphere. So draw free body diagram of the sphere means I will remove the wall. Once I will remove the wall, so which process I will be showing, that is called free body diagram of the sphere. So okay, see the figure, please go through the figure. I am going to explain side by side. I am also giving some information that is very important. You please remember. Okay, what are the information and what I am doing? Look, this is the sphere. First one is here. I will find out what are the forces. Now the forces are 50 Newton is passing through the center mass of the sphere. So yes, sphere center, the 50 Newton. 50 Newton. The wall left side will give a reaction. So you know always, since there is no friction, the reaction is always normal. So tell me, who is a line normal to a sphere? I am drawing a line. Now this is a sphere. Draw a line normal to the sphere at this point. What to do? What to do? So draw a line normal to the sphere surface at this point. Means if you connect the line to the center and draw it. Now this is the line normal to the sphere. At this point, extend up to center. At this point, extend up to center. Extend. So any line going to center is radius or radial line. A radius is always normal to the surface. This is important information. Please remember. It will help you to understand quickly. So since there is no friction, important term. Since there is no friction, the reaction is always normal reaction. If this is a normal reaction, so reaction will be touching the sphere at this point. Now I am removing the wall. Now the wall is replaced by a normal reaction. So you draw in such a way that this reaction is extended, it will go to the center mass. That is center of the sphere or center of mass or center of gravity. Now this string, if you extend the string has to pass to the center mass. Why? Because the reaction and weight 50 Newton, that reaction and weight 50 Newton both are meeting at the center. Since reaction and weight are meeting at the center, the tension has to pass through the center. It will then it will pass through the center. That is the tension. So this is the tension. Actually, tension is a contact point at this point. Reaction is a contact force at this point. But I have extended it to show that in which direction it is going. It is going towards center. This tension is also going towards center. This angle is 30 degree. So this angle is 60 degree. This is the free body diagram of a sphere. Let us draw a separate diagram to draw the free body diagram, so that it will be a clear picture. Okay. So I am drawing a free diagram of the sphere. Look. So I am drawing the free body diagram of a sphere. This is the sphere. Then at the center, the weight is acting, that is here 50 Newton. Then the wall reaction is such that it will pass the center. So this is the reaction R. This is the contact. This is a contact nature. This type of contact type. This reaction is gravity force, non-contact type. Non-contact type, and the tension is contact type here, but if you extend it, it has to pass through the center, because I told you, if a body is in equilibrium under three forces, all forces should be concurrent, means they all should be passing through a common point. So that's why this tension, you make a dot line, then extend it. This is the tension. This angle is how much? As for the question, it is equal to 60 degree. That is called free body diagram of some simple models. This is all about the first video of the free body diagram. Then so we'll go to the next video. In video number 2, we'll be doing some more extra number of problems and some analysis also. So thank you for observing my video. If you like it, please share the video. Thank you.